So you can generalize the right triangle definitions of trigonometric functions so that they apply to any angle in standard position. So we're going to let theta be an angle in standard position and let xy be the point where the terminal side of theta, side's right there, intersects the circle x squared plus y squared equals r squared. So here are the 6 trig functions of theta. Now let's go ahead and label our triangle on this right side. So if we're looking at x and y, think about these coordinate points. So this piece here of the triangle is actually our x value. Then the y value will be this vertical side here. And then the radius is here. Okay, so there's our radius. So if we take a look at the 6 trig functions from what we know before with right triangle trig, we know that sine of theta is opposite over hypotenuse. So the opposite side in this case is y, and the hypotenuse is our r value, so y over r. And then we have our cosine of theta. Remember, cosine of theta is adjacent over hypotenuse. Adjacent is this x value here, and then over the hypotenuse, which is our radius. Tangent of theta is opposite over adjacent, so opposite is y, adjacent is x. So we're really looking at theta here. Okay, that's the angle theta. I know it's talking about this angle theta here, but we're just going to go with the angle inside here. So now the cosecant, secant, and cotangent, we know that's just reciprocals on the other side. Also, just thinking about on tangent over here, x cannot equal 0. So for cosecant of theta, it's just the reciprocal of sine of theta, so that's r over y, and then y cannot equal 0. Secant of theta is r over x, x cannot equal 0. Then cotangent of theta is x over y, and y cannot equal 0. These functions are sometimes called circular functions, okay, just for vocabulary purposes. So the next slide, example 1, evaluate trig functions given a point. So these are not unit circles, and if you think about it, if you have -4 and 3, that radius cannot be 1. So we have to actually solve for it. And -4 is going to be this side here, the x value, right? This is our x, -4. And then the y value will be 3 right here. So we have to figure out what the hypotenuse is, which is our radius. What is that? So you use a Pythagorean theorem. So r equals the square root of x squared plus y squared, or that's square root of 16 plus, I went ahead too far, so that is 4 squared plus 3 squared, -4 squared, 3 squared, so -4 squared is positive 16, plus 3 times 3 is 9, so this is square root of 25, or r is 5. So now thinking about the ratio, so we don't have to think about sine is opposite over hypotenuse, we know it's just y over r. So y in this case is 3 over the radius of 5, and I can even mark this as this is x, this is y to help me along. Cosine of theta is x over r, so that means it's -4 over 5. Tangent of theta is y over x, so that is y is 3 over 4. So another way to remember tangent is y over x is that y over x kind of reminds us the slope. So y over x, tangent of theta. Cosecant of theta is just a reciprocal, so this is 5 over 3. Secant of theta is 5 over -4. Then cotangent of theta is 4 over 3. So go ahead and try the next 3 examples on the right side. Evaluate the 6 trig functions, finding out what is the radius, as well as those 6 functions. Make sure you rationalize the denominator. Let's go ahead and pause the video now and finish it out. Then when you come back, then you will have the answers to that next page. So if you did it, the answers are here. You get 3 root 2, and then you get -√2 over 2, and so forth. Okay, so here are the answers to these problems. Let's go on to the unit circle. The unit circle is here, and we see the circle x squared plus y squared equals r squared, which has a center at 0, 0. And the radius, in this case, is 1. This is called the unit circle. The values of sine theta, because the radius is 1, are just our y coordinates. Y coordinates of the point where the terminal side of theta intersects the unit circle. The values of cosine then are simply the x coordinates of the point where the terminal side of theta intersects the circle. So just think about what we learned just previously. Sine of theta was y over r. But because the radius is 1 in a unit circle, it's y over 1, so that's why sine of theta is y. Cosine of theta is x over r, but because the radius for the unit circle is 1, it's x over 1, therefore it is x. So in the next one, we will go ahead and try some examples using the unit circle to find our 6 trig functions.